Welcome to this Mathcast. In this episode, we're going to be looking at expected value or expectation. This is one of the best applications of probability that we've seen this semester so far. We're going to look at an example, but first I want to define what expected value is and how to calculate it. I'm going to start off by defining a random variable x that has k outcomes. In other words, there's k things that can happen. So here are our k outcomes, and associated with that random variable is going to be a probability distribution. That probability distribution associates with x1, p1, with x2, p2, and so on. I think we know how this works by now. Then the definition that we're looking for is the expected value of x, which we denote as e of x. Now this is the expected value of that random variable. In other words, it's sort of like an average or a weighted average. The expected value of x is equal to, I'm going to throw some math notation at you, and then I'll sort of explain what it is here. It's the sum, remember sigma means sum, it's the sum of all of the random variable outcomes. So I'll call these random outcomes times, you should think of these as weights, but really all they are the probabilities. Written in a different way, what the expected value is it's the sum of each outcome times its associated probability, added up. Alright, so now that we have maybe a little better feel for how to calculate it, let's show actually sort of the ins and outs and how I want you to look at this topic in general. Let's start off with a example. So I want to play a game, and in this game we're going to roll a single six-sided die. And here are the conditions for the game. If you roll a 6, then you're going to win $3. If you roll an odd, in other words a 1, a 3, or a 5, you're going to win $1. And the game costs $1 to play. Here's what I want you to find. Find the expected gain from playing the game. It seems like an easy enough question. Remember, expected value is an average, so what I'm asking you to do is, if you were to play this game on average, how much would you expect to win? And that's really the question that I'm asking you here. Now, in order to answer this question, we're really going to need to set up what's called an outcome table. So let me go ahead and do that right quick. The outcome table is very much like the probability distribution table that I showed you earlier. It's going to have several columns, and I'll label these columns here in a second. The first column, you should list the individual outcomes. In this case, what are the important outcomes? Well, you could roll a 6. That's clearly an outcome that's important. You could roll an odd. It's another outcome that's important. Or you could, I'll just call it other, but you could roll something other than a 6 or an odd. Just parenthetically here below these, here I'd have to roll a 6, here I could roll a 1, a 3, or a 5, and then the other case would be if I rolled a 2 or a 4. So that sort of tells me what these are. Next column, I'm going to include my random variable. The first outcome for my random variable is rolling a 6. Now the random variable, I should define that over here. Let's let the random variable x, let's let that count the amount gained on a single turn. So in the case of rolling a 6, what is the amount gained on a single turn? Well, you win 3, but it costs you $1 to play. So the amount gained on a single turn would only be $2 there. If you roll an odd, you win $1, but it also costs $1 to play, so you're only really breaking even in that case. And then finally, in the case of the other, you're not winning any money, and it still costs you $1 to play, so this is where you actually could end up losing. So the random variable for this problem only has 3 values in it. It has 2, 0, or -1. Those are the only possible values from which to pick. Now the third column is going to list our probability distribution. So what are the probabilities associated with each of these outcomes? Well, the first outcome, rolling a 6, there's only one way to do that, so it's a 1 out of 6 chance. Rolling an odd is a 3 out of 6 chance. And rolling one of the other, 2 or 4, is 2 out of 6. Remember that if you're doing this correctly, there's a couple of properties that the probability distributions should satisfy, and if done correctly, remember this column should equal 1, and in fact it does. So I've set that up correctly so far. Finally, the last column here, and in some ways the most important column for this exercise, list what are called the expectations. The expectations are these individual products. So all I want in this row is to take the random variable and multiply it by its probability. So for this first one, I want to take 2 and multiply it by 1/6. It gives me 1/3. Here I want to take 0 multiplied by 3/6. It gives me 0. And then lastly, I want to take -1 and multiply that by 2/6. That gives me -1/3. Now if you look back at the definition of expected value, I'm expected to sum all the expectations, which means I should add up this last column. Well, if I take 1/3 plus 0 plus -1/3 and add down, that should give me an expected value of 0. So oftentimes I'll write it this way, EV, or expected value, equals 0. Now the question is, what does that mean? Well, it means on average I'll win $0 playing this game. I won't lose any money either. And so in that sense, we call games that have expected values of 0, we call them fair. This is a fair game. I'm just as likely to win as I am to lose, which means that the person administering the game is just as likely to win as to lose. There's not many games out there that are fair games. They're almost always slanted in terms of the house because they need to make money. And by house I mean the casino or the carnival or whoever's administering the game. But just remember that an expected value of 0 means that the game is fair. So this is a very important application of probability. I've walked you through one example here. Most all of the examples you're going to want to go in the order I went here. First by figuring out the pieces of the example, then figuring out what your random variable should be counting, list the probability distribution and the outcomes in an outcome table, and then create the expectation column and add it up to find your expected value. All right, hope you enjoyed this.